let's see if this series converges. And we're going to use the ratio test because it's fun and that's the lesson we're on. And it works in this case. Now the ratio test is when we have to take the absolute value of a series. So let's take a look at this. Just very quickly, let's generate a few numbers in the list. Let's generate a few terms, I should say, in the list. So if I plugged a 1 in for all my n's, I would have -1 to the n, which would be -1, -1 times 1 over 2 to the 1. So there's our first term. Our second term would be 2. Plug a 2 in here, plug a 2 in here, plug a 2 in here, and we would have 2 goes here, so positive, good to know, and then 2 over 2 squared, that would be 1/2. So far, these are going to cancel out, but let's keep going. Plug a 3 in, they're not going to keep canceling out. Plug a 3 in, you're going to have a -3 over 2 to the third. And then plug a 4 in, we'll stop at this one. It's going to be positive because you have a negative to an even power. So positive, and then 4 over 2 to the 4, that would be 1/4. That'd be 4 over 16, so 1/4. So this is what we're dealing with. And the point of me doing this was just to demonstrate that this is truly an alternating series. Sign was negative, positive, negative, positive. Going to keep alternating back and forth. Ratio test. Absolute values this thing, so we are not going to be dealing with the negative component, what I call the toggle factor. It toggles the sign back and forth, negative, positive, negative, positive. So in the process of doing the ratio test, we would take the absolute value, and really the best way to do that in this context is just get rid of this -1 to the n, because that's the thing that changes your signs back and forth. So I can make a habit of putting the absolute value bars on there, but technically it's going to be positive if I leave that guy off. So here we go. The limit as n approaches infinity of, let's use the bars for fun, but the bars mean that this goes away and I'm going to have n plus 1. It's the next term divided by the current term. And the next term is n plus 1 over 2 to the n plus 1 divided by the current term, which is n over 2 to the n. And again, I'm dropping off this -1 to the n because I don't want negatives to show up in this. It messes everything up. I don't like it. So let's keep going with the extremely fun algebra that involves lots of exponent rules. And approaches infinity, absolute value just for fun. N plus 1 over 2 to the n times 2 to the 1 times, and then we'll multiply by the reciprocal, 2 to the n over n. Okay, good to know. And we're going to have a red marker. And we're going to cancel some stuff out. 2 to the n cancels with 2 to the n, and it leaves me with the limit. There we go. The limit as n approaches infinity of, let's see, n plus 1 is my numerator, and 2n is my denominator. And as I approach infinity with this, I'm kind of looking to see what I have here. I have n plus 1 over 2n, and this is like a horizontal asymptote situation. If this was a function, not a series, I would basically have like x plus 1 over 2x, and the horizontal asymptote would be at 1/2. So this is 1/2. Well, that's fantastic. Here's what I really need to know. Does this series converge or diverge? Well, I'm using the ratio test, so we compare it to 1. 1/2 is less than 1. For that very reason, the series that I don't feel like writing again, could write the whole thing again if I wanted to waste my time and ink, but I'm not. The series converges. Converges? Yes, it absolutely converges. Absolutely. What does that mean? Because this series is alternating, and I say that the series converges absolutely, then that means that the series will converge whether I'm dealing with this, that converges, or whether I'm dealing with this. Okay, so remember at the beginning when I started making a list and the signs were alternating? That one converges. However, if all my signs were positive, that one would converge as well. And that's what it means when it says the series converges absolutely. It converges whether you're dealing with the alternating series with the signs or just straight up positive. That's it. Good to know.